All right, welcome back. So today we are going to be talking about a new topic called direct variation, but it's not brand new. It's just going to be taking what we've done with slope and we're going to be applying it into an equation. So without further ado, let's have out those guided notes and let's begin. So a direct variation is a special type of a linear relationship. It can be written in the form of y is equal to k times x, where k is a non-zero constant called the constant of variation. So all we are doing is we're taking this constant of variation and we're multiplying it by x. We're saying, hey, y is going to be equal to this value k, and it can't be 0 because 0 times x is 0, so then y is 0, right? So it's any non-zero constant, any non-zero number, and we're going to be multiplying it by x, and then we're going to get our y value, right? If we think back to when we had y is equal to, I don't know, 3x, right? Before we've done where it's like y is equal to 3x, and we wanted to find some values, right? So we would say, oh, if x is 1, then y is 3. Therefore, we get 1 comma 3. If x is 2, then y is 6, and we get 2 comma 6. So on and so forth, right? So this was an example of direct variation. We've actually been working with it, but now we're going to formalize it. So you can identify direct variations from either equations or if you're getting ordered pairs. So let's look at the first when we're dealing with equations. So let's tell whether or not 2x plus 4y equals 0 is a direct variation. If so, we want to identify that constant of variation, right? The value of k. So in order for us to do that, we first need to get it into the form of y equals kx. Right now, it's in standard form, and it's not in direct variation. So we have to move it around. We have to shift it to get it into y equals kx. To do that, we're going to subtract 2x on both sides, or add negative 2x, but I like to say subtract 2x. Then we get 4y is equal to negative 2x. Then we divide by 4 on both sides, and we get that y is equal to negative 1/2 x. Whoop, that was really weird. Let's see if I go back. No, I don't like that. That's okay. Too late. So then we divide both sides, and we get y is equal to negative 1/2 x. Now that we're in this form of direct variation, we can say y equals kx, so k has to be negative 1/2. That constant of variation has to be negative 1/2 because y equals kx, and now we have a coefficient of x, that constant of variation, and that has a value of negative 1/2. Awesome. So that's how we look from an equation, right? If we're given y equals kx, then we can just identify. But sometimes we have to manipulate our equations to get it into the form of direct variation. Now, sometimes we're going to be given equations, and sometimes we're going to be given a table. So we are going to be given a table of values. We have x values with their corresponding y values, and we want to see if we have a constant of variation, if the changes are constant, right? So just like with slope, what we can do is we can solve to get k all by itself. If we start with y equals kx, then we can get it to be k is equal to y over x. So now what we can do is find k for each ordered pair. And we're going to divide the y value by the x value. If they're the same, then it shows a direct variation. So this is going to be a set of direct variation, because when we divide each y value by the x value, well, we get the same overall value, right? This first set right here, 1/2, is 1 divided by 2. This second set right here, 2 over 4, comes from this set. And likewise, the 6 and the 3 goes into here. And when we simplify down, we get the same overall value of 1/2. Therefore, we can say this is direct variation because we have the constant of variation equaling 1/2. Awesome, awesome, awesome. Please work on the guided notes for the front page and then resume when you're ready to move forward. All right, perfect. If you're listening to my voice, it means you worked on the questions of the guided notes on the front page and you are now ready to work on or to talk about the back page. Awesome. So for this side, if you know one ordered pair that satisfies a direct variation, well, you can find and then graph the other ordered pairs that will also satisfy the direct variation. So if we look at the values of y varies directly with x, and we're given that y is equal to 8 when x is equal to 24. We want to figure out when y is going to be when it's equal to 27, sorry. So in order for us to do that, we have to do a little bit of manipulation. So we have to find how the y varies with the change in x. And then we're going to be able to find the value of y when x is equal to 27. So we're going to use the equation for direct variation and substitute in our values. We know y is equal to 8. We know x is equal to 24. So now we're going to solve for k by dividing by 24 on both sides and then simplify. When we simplify, we get k is equal to 1/3. So now we're going to write the direct variation equation. We have y is equal to 1/3 x. Right, y is equal to 1/3 of whatever x is. And now we're going to substitute in the values that we know to find that y is equal to 9. And that is how, if we're given a couple values, then we can figure out another value. You might have thought in your head to do a proportion, and this is very similar to a proportion. We're just taking it and writing it into an equation now. That is really the only major difference, right? Awesome. Awesome, awesome, awesome. So now we're also going to be talking about some real life examples. So it says a garden snail can travel about 2.6 feet per minute. Write a direct variation equation for the distance y a snail will travel in x minutes, and then graph. So the first thing we have to do is write the equation. Well, we know direct variation is y is equal to kx. So now we know that our distance is going to be equal to 2.6 feet times our minutes, right? However long. It's going to travel 2.6 feet every minute. So if we know that it's 2.6 feet per minute, well, we have y is equal to 2.6x. Now, we can generate some ordered pairs, just like we have done before. We can take some x values, substitute them in, get the corresponding y values, and plot those points. So if x was 0, 2.6 times 0 is 0. Therefore, the ordered pair is, well, 0, 0. If x is equal to 1, then we have 2.6 times 1, which is 2.6. So y is 2.6. Therefore, we get the order pair 1, 2.6. And we continue on and on and on. And then we graph. And notice where our graph is starting. Our graph starts always in the origin. We'll always start in the origin. In order for us to have direct variation, we have to start at the origin. And that is very important moving forward because soon we're going to be taking this idea and expanding it even more. So in order for it to be specifically direct variation, our graph has to be starting at the origin. Awesome job today, folks. Please work on the problems for the guided notes on the back side of your worksheet. And let me know if you have any questions. Keep up the great work, and I'll see you soon.